Video games have levels and worlds, at the end of which you have a boss fight. At least, for the most part, that's the structure that you can boil most video games down to. So, if you've caught any of my live streams over the last few months, you've seen me building up one of these boss fights for my game, starting with the modeling, lots of modeling, all the way through animation, programming, and you've seen every single issue we ran into. Okay, I do have an ability to actually straight up push him around. Probably shouldn't be able to do that. This is really goofy. But all that together is literally about 40 to 50 hours of live stream footage, which, if you want to watch that, be my guest. Do get a YouTube Premium subscription before you do, because watch time. Thanks. But for any normal people in the audience, let's go over the whole journey in the next 10 or so minutes instead. So even before I started making the model, I had a pretty good idea what this boss fight should look like and how it should work. Meaning that I knew a few things from the get-go. The design should be able to float and not rely on having legs. To be honest, that's half my characters, because it saves simply a bunch of time on making walk animations if a character doesn't have legs. Being a solo dev, I try to make shortcuts wherever I can see them, and this boss is supposed to be a Grim Reaper-like character, so I already had the model of a skull and a model for some skeleton arms, because I made those for other assets in the game. So I could just reuse them, putting them together, using some sculpting tools to modify them ever so slightly, and here we are. Now the only thing that I really need to model is the ribcage and the spine. Well, so I thought, because I also wanted to give him a cloak. And this one decision probably made this whole boss fight take about 4 times as long to create as was needed. So, the cloak. It needed to be able to simulate physics. It's supposed to work as a cloth, and I am not going to hand animate that. It would look a lot worse, and it would be so much work to animate. So instead, I want to just fully rely on some light clothing simulation in engine. Well, that means that the topology for this needs to be at least halfway decent. So after we sculpted everything into place, which was the easiest way to get the cloak fitting around the already existing body, now I had to go through and retopologize the whole cloak by hand. For the rest of the model, I could rely on more automatic solutions like decimating, but for this, it needed to be good. And for some reason, it needing to be good didn't make me think that I should download a retopology plugin to help me with this process, so I did this vertex by vertex all by hand. Which, look, I don't want to talk about it. All that said, having all this insanely high poly detail on the model does really help with baking the textures. Because in Substance Painter, not only is it easy to bake those down into a normal map onto a lower poly model, which will make that one look way more detailed than it actually is, it is also actually used to create all of the color textures, allowing me to easily put in detail there without having to paint it on, because I already sculpted it on. It just gets baked down into a couple of different texture maps. Now, I'll be real with you guys, doing the cloak took up about half the time or so of this project in its entirety. And as it stands right now, as I record this, I still need to fix up a couple of little things, because the clothing simulation works for the most part, but it tends to clip through the cloak in weird places throughout the body. And setting up the physics asset in Unreal for the collision with itself is a little bit iffy at times. I'm sure eventually I'll get it right, and surely this wasn't a huge waste of time, right? Surely. Let's move on. But not before we talk about today's sponsor, Skillshare. As you can see in this video, making even a small part of a video game takes so many different sets of skills. And while on this very YouTube channel you can find a lot of educational content about some of those skills, it can be really difficult to get a handle on all of them. And that is where Skillshare comes in. On Skillshare you can find educational content on near anything that you could be wanting to learn. So take me for instance, I myself would mostly identify as a programmer, even though I'm kind of all around, but for sure my skills in making art assets are where I lack the most amount of confidence. So by following a course or two on Skillshare that is structured to help me learn in the most efficient and direct way possible, I can improve my skills and keep on developing and keep making my game better and better and better. Follow the link down below in the description of this video to get your first month of Skillshare for free and start learning right now. Next up was rigging. And like I surely mentioned in some previous videos, I've been trying to move over most of my rigging and animation work into Unreal itself, rather than in Blender. It's really nice to just be able to open an animation sequence, change a thing or two, save it, and instantly have everything updated in the gameplay, without re-exporting, importing, and all the potential issues that come with that. Besides, since this is a boss character, you'll probably also need to have an introduction cutscene too, which cinematics like that you really want to animate in engine where you can, I'd say. Not just animate them in Blender and then just hope that things line up properly inside of Unreal. The only issue is, I am by no means the best rigger or animator in the world. I can get by, but I quickly tend to regret not doing things in a slightly better way, and then finding out about those regrets when, generally speaking, it's really too late to fix them. You want an example? Let's do an example. Inverse kinematics. My whole rig for this guy is just based on forward kinematics, because, and this part actually does make sense, the arms only really move in rotational movements. The swing of a weapon is a motion that is created by the rotation of your joints, not by leading your hand in a straight line from point A to point B. So really, for the arms that wasn't an issue. Forward kinematics makes sense there. Strangely, the issue was with the spine. Usually the spine pretty much always requires a forward kinematic setup. Rotating one part of the spine should always also rotate everything above it. You don't really find yourself wanting to twist a spine all over the place based on positional data all that much when you rig or animate a character. But since this is a floating skeleton, there was quite a unique situation where the spine functions, of course, as a spine, but at the same time almost like a leg as well as a tail. So when I want to animate this character dashing forward, I want the spine to be able to move back and up without also then messing up the rest of the torso for the character, which I could have accomplished with inverse kinematics. I managed to make it work, more or less, but you know, I'm not an animator, so please do try to cut me some slack. Now, with animations working well enough, it is time for the fun part, coding, or is it? Because we need a place to fight this guy, right? So yeah, I spent a whole stream just building that arena. The idea is that it's sort of like a king's tomb. You fight in the middle part and there's a bloody fountain in the middle. Honestly, mostly just to break up the empty space of this level, and also to strengthen the whole circular shape of this arena, because the boss will only move around in a circle around the center of this map. Unlike a lot of other enemies in the game who just go straight for the player, this guy has some more intelligent and complex movement mechanics. The pillars around the outside of this arena we will talk about in a second. My previous boss fight was a mess as far as code goes. So for this guy, I wanted to check out state trees instead of behavior trees. A state tree is more like a state machine, where any states can move into any other state if the right requirements are met, but also has the benefits of a behavior tree, where its default behavior on completion of any state will be to run the tree again from its entry point. I really do like the sound of this system, but as I started playing around with it in a separate project, I found that it is not particularly finished yet. It lacks pretty much any sort of debugging tool at all, meaning that no, I cannot actually put it into proper use. So instead I stuck with behavior trees, and I just figured I'd need to code a fair bit more of my own nodes and my own tasks to make this work. You see, one of the things that I want to be able to do is for the boss to enter a passive state after a certain amount of time, kind of just like a waiting node. But while Unreal offers a waiting node for its AI components, it is not possible to link the length of this waiting node to a variable by default, so I needed to create my own node that does something like that. And for this boss, I ended up doing a lot of little things like that. Now I have one functioning node that does a bunch of updating code about 2 times a second for the boss fight, getting its current HP and based on that setting a bunch of other values, including how long the boss fight stays aggressive and how long it stays passive, and possibly even whether or not it is likely to do a certain attack or not. This kind of thing is mostly what I've been struggling with when coding my bosses up until now. That is the different phases of a boss fight, without just copy-pasting over a bunch of nodes, because that makes the tree grow way out of proportion and makes it really annoying and bothersome to change things about the code, because now the same code exists in 3 places, which as a general rule of thumb is just very bad to have. But all that is now fixed with a much more simple and much more workable type of behavior tree, which does support different behavior for different phases. Anyway, all that is fixed up now, so let's take a look at what this guy can actually do. First and foremost, he has a dash attack, where he dashes toward the player and swings a scythe at you. He has a attack where he can shoot a projectile at you, and he can do his special attack. The special attack is what causes him to go from his aggressive state into the passive state once the attack is over. During this attack, he will vanish from the battlefield altogether, and one of the skulls on the pillars around the arena will start following the player around with glowing eyes. You need to figure out which one is looking at you and quickly, because after a couple of seconds, the boss will spawn on top of that pillar and dash toward you, quicker than with his usual dash attack, to attack you. All that does bring up one fantastic issue still though, and that is that the attack animations are pretty static. It's just play this animation, and if the player doesn't happen to be in the place where the scythe gets swung, it's not intelligent enough to really aim at the player per se. So if the player is too close to the boss, which you probably would be because you're gonna try to get up close to attack it, the boss will just swing past the player instead of at the player, and that isn't very threatening. So I could do a lot of complex inverse kinematic stuff in real time, but that would be hard because, well, let me explain. Having him just punch the player wouldn't be an issue. That would be super easy. I can just say, hey, move the hand to this location in space and be done with it. But this boss fight is holding a weapon, so how do I calculate where the hand needs to be in order for the blade of the weapon to overlap with the character? That's going to be an absolute nightmare to do. I suppose I could just kind of trial and error, finding a middle position between the player and the boss with some clamping on either side, but that seems still not like a great solution. So if I wanted to do IK, I would need to set it up so that the weapon itself has a bone that I can use to drive IK for the hand and the rest of the arm. But this deep into the development of this boss fight, I don't really think that I want to be updating the skeleton, because if that breaks anything at all, I'm going to have a bad time. So what did I do? I just moved the boss character up and back a little bit. It's already facing toward the player because its code says, hey, when you attack, rotate toward the player. So just making it slide back a little bit pretty much fixes the issue, because that lines up the swing of the scythe with the player. Now, the amount that it slides back is based on the distance it has at the start of the attack to the player. So it's pretty much always going to move itself into a position where it can hit the player. And again, do you see what the benefits are of a character that doesn't have legs? Because if this character was grounded, this would not have been possible to do. Now, this whole video was a short overview, of course. The entire process took about 40 hours start to finish, and the whole thing is here on the channel if you do want to watch it. All my idiocy included. Even without making mistakes like that though, which realistically you will make those mistakes, it just shows you how one singular thing in making a game can take up so much time. Making this one thing doesn't make a game. There's tens, if not hundreds of these singular things that need to be made that come together to make a video game. So I guess I should probably be getting back to work now, eh? Yeah, I'll see you all back with the next video. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,